This video is about the end behavior of polynomial functions. So just a quick explanation of end behavior to get started. Suppose you have an XY graph and on it there is some type of function. Maybe it looks like that. Now, by end behavior is meant what happens as x moves to the right, in other words the right hand end, and in this case we can see that the function is proceeding in a downward direction, and so the right hand end behavior is downward toward negative infinity for the y value. Now on the left hand side for this particular function we can see as x moves farther and farther to the left, the y value for the function is moving upward toward positive infinity. So the left hand end behavior is toward positive infinity. Now, when you're dealing with a polynomial function, as an example, y equals negative 2x to the fourth plus 3x squared minus 7x plus 2, there is only one term, the highest order term, this term, negative 2x to the fourth, the one with x to the highest degree power, that will actually determine what will happen when x gets very large, in other words goes to the right, or x gets very small, in other words x goes extremely far to the left into the negatives. The term with the highest power will become by far the largest term, and it will control the behavior of the function. So all we really need to know is the highest order term and think through some consequences. Now, in this case, negative 2x to the fourth. If we think of x as some extremely large positive value, raise that to the fourth, that will be a positive number. But we must then also, at the end, multiply by negative 2, so the right-hand end behavior of this function is downward. Now, on the left-hand side, let's think of some large negative value for x, maybe negative 100. If you take negative 100 as x and raise that to the fourth, you will still get, because this is an even exponent, a positive result. However, you still need to multiply by the coefficient negative 2. The end result is that on the left-hand side, this polynomial will also travel downward. So this sketch is a partial sketch of the polynomial. We have not mentioned what will take place between the two ends, but at the far right-hand end it travels downward, and the left-hand end also downward. Now, in blue here, let's make a little chart of possible results. The highest order term will always have a coefficient and an x value raised to some integer exponent. That integer exponent, which I'm right now calling n, can be either even or odd. The coefficient can be either positive or it could be negative. So putting all these results together, we can summarize in a small table. The coefficient can be positive or negative, and the exponent can be even or odd. Coefficient can be positive or perhaps negative, and the exponent n can be even or perhaps odd. Now, if we have a positive coefficient with an even exponent, that means the end behavior will be up to the right and up to the left. Second possibility, if we have a positive coefficient with an odd exponent, that means the right-hand end behavior will be upward and the left-hand end behavior downward. if we have a negative coefficient with an even exponent for the highest degree term, the right hand end behavior will be downward, and so will the left. And finally, if we have a negative coefficient with an odd exponent, then the right hand end behavior will be downward, and the left hand end behavior will be upward. These are the only 4 possible cases. So let's do one more quick example. Suppose we have y equals 4x cubed minus 5x squared minus 8x plus 3. The only term that's of any significance for end behavior is the highest order term, and we can see that the coefficient for the constant is positive, and we can see that the exponent, x cubed 3, n, is an odd number. And so if we need to consult the chart, c is positive, n is odd, and so the end behavior will be such that on the right hand side it goes upward, left hand side downward.